Namaskar and welcome to Baat Pachisi. On Baat Pachisi, we are going to discuss a very important subject of engineering, a section or branch of engineering that is mechanical engineering. And having studied mechanical engineering in Punjab Engineering College, Chandigarh from 1973 to 1977, and later working on the manufacturing sector, I have some little information of what is involved in mechanical engineering, what the engineers do, what they are expected to do on the shop floor, in design office, or in problem solving area, or conceptualization of a new manufacturing system, or analyzing a defect in a manufacturing system along with its possible improvement to increase the efficiencies, reduce the downtime, and other benefits which can come with the add-on technologies, like so many areas of digitization, computer aided systems, and lately the artificial intelligence. So we dive into the subject right from the beginning, that what is mechanical engineering, what mechanical engineers are expected to do broadly. There are so many areas where they have to work in a specific specialization. There are so many areas. I mean, there are very few people who have the opportunities to work on a different segment of mechanical engineering, from designing a system, from problem solving, from manufacturing a component, from designing and manufacturing a manufacturing system like a machine, try to and improve the existing machinery, or building a new modified version of a machinery, or a production system, or a transfer system, or inspection system, or the shapes changing system. So there is a wide variety of activities a mechanical engineer is expected to do, but he will remain fixed in a core area wherever it is, whether it is research and development, or on the shop floor manufacturing, or the problem solving and the processes. So it involves right from the application of scientific principles of mathematics, physics, and material movement, and all the scientific formulas to realize a particular system which can best aid into manufacturing sector, which is very wide, right from the component manufacturing of a nano component to large machinery like tunnel boring machine, railway system, aircraft. So it is and even the utensils we use in everyday work at home. So whether they are made of stainless steel or some other material, or bone china. So the machinery, work of machinery comes into it. And the most important thing which moves us is the car, which is a part, the car, manufacturing of a car or automobile, to be a better description, from two wheelers to four wheelers, or from the large trucks, has changed the human civilization to the levels what we see, operate in, and experience, and try to sometimes better in whatever capacities we are. So we go back to what is mechanical engineering. So mechanical engineering is one of the oldest, broadest, and the most versatile branches of engineering. It is the discipline that applies the principles of physics, mathematics, and material sciences to design, analyze, manufacture, and maintain mechanical system. So this is right from the beginning. Design, analyze, manufacture, and maintain mechanical system is basically the mechanical engineering. That is the core definition of mechanical engineering. The functions are design, analyze, manufacturing, maintain the mechanical system. And now the widespread is the micro scale of the medical devices and nanotechnology to the macro scale of aircraft carriers, spacecrafts, power plants. Mechanical engineering touches every aspect of modern life. It is fundamentally concerned with anything that moves, stores energy, or converts energy or form from one to other. So this is the broad definition of the understanding of the disciplines involved, of the responsibilities involved. Now we go to the next level. What exactly mechanical engineers do? So mechanical engineers convert conceptual ideas into functional physical realities. Conceptual idea. If somebody has a very simple idea, to maybe an example of a processing of a fruit or sizing of a fruit or identifying a defective fruit from a healthy fruit. So this is a concept. Now you have to conceptualize what will happen into this physical reality, how it will happen, what will be the transfer system, what will be the inspection system, what will be the rejection and acceptance gate system. So they are the mechanical engineers, are basically the problem solvers who design devices, machines and systems to improve the human efficiency. In an automobile or a scooter or even a cycle or even a lever, which is the most basic and first machine we can say is a lever. So that improves the human efficiency. A large 1 ton or 2 ton stone one person cannot move, but with the help of a lever that is possible. Further on, what situation it is, how it is there, what is the, so many environmental issues will define what kind of a lever it will be. So that is what exactly the engineers do. So now in what they do is research and development, and having worked in taken the responsibility of research and development of a machine building system, I myself can have a little idea about it. So they research feasibility, test advanced materials, explore new engineering methodologies like fluid dynamics or thermodynamics to create next generation technologies. Thermodynamics was for me a most interesting but a difficult subject to study in the engineering, whereas the machine drawing has a large interest. So these are the background I am sharing with you. Now the how do you design? The previously everything was on the drafting machines. Generally we are talking about the engineering in modern times. The now there is a improvement of the computer aided design, CAD and simulation methods. So engineers use advanced softwares like SolidWorks, ANSYS and AutoCAD to create highly detailed 3D modeling of the components. They run virtual stress analysis. Without being the product being in the physical shape, it can put through a various stress analysis and thermal simulation process, fluid flow and a test to predict how a part will behave before even it is physically built. So having a one component with one material, one dimension, and it goes through these analysis, so the dimensions or the material or the shape can be improved to have the better efficiencies of operation. And now the next work is the prototyping. Before going for the final and mass production or whatever level, to certain build machines, one machine is always a prototype, but to build 10 machine, is a mass production. Sometimes building a lakh piece in a year is also mass production. So it will depend on what kind of component or system is being manufactured, what are the precision levels, what are the components, what are the materials, what are the processes required to manufacturing it. So the prototyping and testing, it is what it is experimental modeling prototype of their design subject to extreme real world conditions such as extreme heat, vibrations, structural loads, to identify failure points and redefine or refine the design processes, and system diagnostics and the maintenance. I mean, after the creation of a system or a product or a machine, there is a continuous process where the engineers analyze mechanical failures, optimize the machine performances, and design preventive maintenance system to ensure long-term safety and reliability of any simple or even a complex machinery. So now we go to the next subject, so role of a mechanical engineer in manufacturing industry. So there where the manufacture, mass manufacturing or whatever level of manufacturing of a component or a system or a machine. So mechanical engineers work across diverse fields like aerospace, automotive, biotechnology. I mean, these are the broadly the widest subject. They serve as the fundamental backbone of the manufacturing industry. I mean, they have to go back to the drawing board. They have to analyze so many scientific systems and principles and apply them to improve a product or solve a problem. So they are the architects of the production line. As an architect designs a house, the mechanical engineers are architect of the production lines or production system that turns raw material into finished consumer product. It may be a spoon, it may be a highly sophisticated car or even a computer to certain level, and the role of the modern manufacturing can be broken down into the critical areas. And what are those critical areas? Number one is the product design. Number two is the process and automation planning. Now, I mean, everything or any manufacturing automation is a new subject, but in manufacturing, the process and the automation planning, how can we automate it? Definitely, will the automation solve the cost or improve the efficiency or accuracy to a certain level? And then designing jigs and fixture, how a component when it is processed, that means whether it is inspected or it is machined, how it will be held on that machine. So tooling and jigs and fixtures are important part into this, and the quality and the life cycle management. So these are the modern manufacturing, these are the roles. And right from the beginning, at the designing of the machinery and tooling, manufacturing requires highly specialized tools, robotics, assembly lines. So mechanical engineers design and automate robotic arms, computer numerically controlled machines, conveyors, hydraulic presses used on the shop floor manufacturing. They also design custom tooling, ties, molds, jigs and fixtures. Those who have really worked on a shop floor and done a manufacturing process, machining and some inspection processes, they will definitely understand what is the importance of the jigs and fixtures. Sometimes a new component comes and it has to be machined on a milling machine. So it cannot be simply put there and bolted. Sometimes we need jigs and fixtures to improve the loading and unloading time, and that's how they improve the processing of that component on that particular machine. So process optimization and the production efficiency is very, very important what they do. Mechanical engineers set as a process architect They analyze the layout of a factory floor to reduce the minimum material handling time, optimize heat and energy usage in thermal processing units, eliminate bottlenecks by applying concept like lean manufacturing. Lean manufacturing is very very interesting subject. We will definitely deal on that. And the Six Sigma, they ensure the goods are produced with the lowest possible material waste, cycle time, and the cost. And driving automation industry 4. So industry 3 to industry 4. The modern manufacturing plant is heavily in a digitized. Mechanical engineers work closely with the electrical engineers, software engineers to implement mechatronics, the convergence, which is the convergence of mechanics, electronics, and computing. They deploy an automated guided vehicle, integrate smart sensors in manufacturing equipment, and real time data storing, and develop automated assembly sequences. And the quality control, safety, and the structural integrity, ensuring that the thousands of identical parts meet exactly micron level tolerance. And having worked in manufacturing component with plus or minus 5 micron tolerance, I have little understanding of what it involves. How interesting it is, how systematic and time consuming this area is of the precision manufacturing. That is the core engineering challenge. So mechanical engineers design automatic inspection systems, use non-destructive testing, you know, and methods like ultrasound of the X-rays to check the internal material flaws, and establish safety protocol to protect factory operators from high pressure and high velocity machines. So this is the core area of specialization is mechanics and machine design. That means designing gears, linkages, bearing, structure to withstand the forces without breaking. Thermodynamics and heat transfer, that means managing cooling system for heavy factory machinery, electronics, optimization of the industrial furnaces. In the material science, selecting the right kind of material is very very important. Composite or polymer based or structural, on structural wear, corrosion, and the cost constraints are taken into this. And the fluid mechanics, designing hydraulic power system, pneumatic filters, and the air filtration system for the clean room manufacturing. So we can conclude the mechanical engineering is the driving force behind the industrial capability of any society or a country. By bridging the gap between scientific theory and physical production, mechanical engineers do not just design isolated component, they build automated, efficient, and sustainable factory ecosystem that powers the global economies. So this is in nutshell what mechanical engineering is, what broadly mechanical engineers are expected to do. So we hope that this episode on mechanical engineering is interesting to you. So please subscribe and share the link with your friends and relatives, and fellow engineers and others who have engineering in the student also, to understand what mechanical engineering is in a very very simple and broad sense. Thank you very much. Thanks for watching. We'll be back with a new episode to talk about some other interesting subject. Thank you.